I will give you an overview about Green Labs, about energy efficiency at Boehringer Ingelheim. And I will give you some topics about how easy it is to save energy. It's not really hard to save energy, but we have to look at the buildings, we have to look deep inside, and we have to look what the users really need inside. And we know what our buildings need energy. And we know, for example, the office buildings have an amount by around about 2.5% of the whole sites of BI. Boehringer Biberach and Boehringer Ingelheim are sites with a lot of labs and production buildings, and the office buildings do not use really much energy. But let's start. Project cost. Maybe all of us know that operating costs are really much higher than the cost we need to build a building. And this is why it's really important to define really a clear structure when we plan and construct a building, because afterwards it's really much more difficult to change anything. When we don't have the flexibility to optimize during operating of a building, it's really hard to optimize anything. Now let's have a look at the energy consumption for a standard lab building. A standard lab building maybe for a research lab. We see one for winter time and summertime, and we see that the process equipment and the air conditioning are the most important energy consumptions. Illumination in wintertime, okay, but in summertime, that's not really much. And therefore, we started, I think, 25 years ago to reduce energy consumption, and we started with the equipment and with the air conditioning, because there we saw that we could really reduce a lot. And what did we do? We found out, we structured it in three parts, in three topics. In structural measures, for example, are really flexible buildings, flexible layouts, flexible architecture, and flexible technical systems. Then technical measures. I highlighted the first and the third one because there is really much, the potential is much higher to reduce energy. And the mode of operation. The mode of operation is, it means the parameters, airflow rates, temperature levels and so on, pressure levels and so on. And there we saw the potential is really enormous to reduce and to optimize. Here we see some topics we saw that we could reduce really a lot. And let's start with the air exchange rates. We found out that 1 cubic meter air per hour costs around about €2 per year. Therefore, if you have a building with 500,000 or with 1 million cubic meter air exchange per hour, you can save really enormous when you reduce the air exchange rate by around about 5 or 10 or 15 or 20%. Therefore, we focused at the beginning of our optimizations on the air exchange rates and on the quality of the air. For example, humidification in wintertime, we saw that we need a lot of steam to have a really good air inside, because the cold air comes inside, and when it's hot, when it's normal temperature, room temperature, it's really dry, and then you need to steam, for example, to have a good air inside. And only this humidification, we calculated it. We made a calculation about saving potential, and we saw that in the site of Biberach, we could save by around about 1.5 million, between 2 million euros per year, only to reduce the humidification in wintertime. And we reduced it in a way that we we set the level to 0% night, Saturday and Sundays off work time. And in working time, we reduced the level from 50% to around about 40% humidification rate. And what we also see that we needed to look at the buildings inside and to check the temperature levels, to check the airflow rates and so on. And we saw that in a lot of rooms, we did not need the parameters that was defined. Therefore, we could reduce a lot. Maybe in labs or in some rooms that are really not needed for normal laboratory areas, we could reduce enormous airflow rates. Maybe storage areas for something, paper or so on. You don't need a lot of air exchange rate in such rooms. Then another topic is dynamic air pressure. When you have a flexible air exchange rate, maybe in daytime and the night when the people are off work, we have a lot reduction of air exchange rate. And therefore, it's really important to reduce the ventilation. If you do not reduce ventilation, the pressure in the ducts are really too high. And you need enormous, much more electrical energy, and you destroy a lot of energy. What we also heard that a heat and a cold recovery system is really important to recover the energy that otherwise goes out to the atmosphere. It's lost when you don't have a heat and cold recovery system. And for everything, it's really important to have a flexible automation concept with maybe with a data server. If you don't have any data about parameters, about temperature levels, about pressure and so on, you will not be. It's not possible to optimize anything without data. When you don't know what the technical systems do, what you have inside your rooms and your areas, there's no possibility to optimize anything. Now let's have a look at our test building. It was built between 2003 and 2005. It's a lab building, really a bigger lab building with special labs inside, and we planned it and we constructed it. And it was really a energy efficient, a really high energy efficient lab building. This was our test building. It was built in between 2003 and 2005. And it was a high energy efficiency building when we built it. But we used it as a test for an enormous reduction of energy. And we tested, for example, the humidification, reduction of humidification, air frequency rates, and so on. And we see that between 2006 and 2012, we reduced the energy consumption in this building by around about 50%. And what we did was only changing in parameters. We had a look in each room and checked what is really needed. When the people are off work, they don't need any temperature by around about 22 degrees. They don't need any air frequency rate when there are no drugs inside or no substances inside. And then we did really hard breaks and reduced whatever we could reduce. And the result was we reduced the energy consumption by around about 350,000 euros a year. The price basis was 2014. But we only needed around about 60,000 euros only for changing of software and parameters. It was not really much to put inside. We did not need much money and we could save a lot of money. And when we saw the result, we transferred these results to the whole site of Biberach and to the site of Ingelheim. And here you see the result for the whole site. And you see here a figure, it begins in 2003 up to 2021. The site was increasing by around about 52% floor space. And the energy purchase, and this is the energy that comes in the site that we buy from outside. It's electrical energy and a little bit of fuel. It's not a calculation, it's a hard purchase in kilowatt hours. And you see that we reduced the energy consumption for the whole site by around about 8%. The energy consumption of 1 square meter floor space was reduced by around about 40% for the whole site. And this is really enormous. And here, the last slide, here is the site of Biberach where we did this. A lot of production and lab buildings. Where the site, we have around about 7,000 employees there. And we have a lot of production and lab buildings, not really many office buildings. And therefore, we could reduce really such an enormous amount of energy. Thank you very much.